This is video 3, and we are on page 392 now, and we are quickly going to go through these properties of parallelograms, and then we're going to look at their converses in lesson 6-3. So I'll quickly run through these. I'll flip over and show you the converses in lesson 6-3, and then we'll start looking at some application. All right, so the next property of a parallelogram is that if a quadrilateral is a parallelogram, then its opposite angles are congruent. So you see here that the opposite angles A and C are congruent, and B and D are congruent. To be opposite angles, that means they share no sides. Let's look at the next property. If a quadrilateral is a parallelogram, then its consecutive angles are supplementary. So now we're not looking at opposite angles, we're looking at the angles that are next to each other, like A and D and A and B. And what this property and this theorem say is that those are always going to have to add up to 180 or be supplementary if this is in fact a parallelogram. So A plus D would equal 180, and A plus B would equal 180, B plus C would equal 180, C plus D would equal 180. All right, moving on to the next one. If a quadrilateral is a parallelogram, then its diagonals bisect each other. Now remember what a bisector is. It always cuts in half. So diagonal AC is going to bisect or cut in half diagonal BD and vice versa. BD is also going to bisect AC. Okay, so now let's flip to page 398 and 399 and start looking at the converses of those, which is just going to be simple. All right, so the converse of the first one says, this is 6-3-3, if both pairs of angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So we simply reversed what we were saying. Let's look over here at 6-3-4. If an angle of a quadrilateral is supplementary to both of its consecutive angles or both angles on each side of it, then the quadrilateral is a parallelogram. So in other words, looking at the diagram, if X is supplementary to, well, let's say if angle A is supplementary to angle B, then they are going to add up to 180. So we can say angle A is X, we can say angle B is 180 minus X. We could say the same thing about D, and of course C would also have to be X. So again, remember that the opposite angles are congruent. The consecutive angles are supplementary. So let's also say, just getting ahead of ourselves a little bit, let's say that this angle were 80 degrees or was 80 degrees, then that means that this angle would have to be 100 degrees. This angle would have to be 100 degrees, and this angle would have to be 80 degrees, because remember, all of the consecutive angles have to be supplementary. Okay, let's look at the last converse from what we learned in lesson 6-2. If the diagonals of a quadrilateral bisect each other, then it is in fact a parallelogram. Okay, that is just simply restating in reverse order what we looked at in 6-2. So let me jump back over there and we will start some application. So I am on example 1 on page 392. The diagram shows the parallelogram-shaped linkage that joins the frame of a race car. Here's the race car and here's its wheel. Oh, sorry, I didn't show you that. Here's the race car, here's its wheel. Okay, I forget you can only see small sections at a time. In that quadrilateral, which is PQRS, QR equals 48, RT, right here, half of the diagonal, equals 30, and the measure of angle QPS is 73 degrees. So I have done what I've told you to do in geometry. Always draw, label, and that's exactly what I've done right here. So the question asks us to find each measure. We want to start by finding the measure of PS. Well, remember that one of the properties of a parallelogram is that opposite sides are congruent. So if QR is 48 centimeters, then PS also has to be 48 centimeters. The next one says find the measure of PQR. PQR. Well, we know that angle P is 73 degrees, and we're not looking at opposite angles, we're looking at consecutive angles, which means they have to add up to equal 180. So, to find Q, or PQR, we can say 180 minus 73, and that would equal 107 degrees. So, angle Q, or PQR, either way you want to name it, would be 107 degrees. And the last one says, find the measure of PT. Well, here is PT. It is half the diagonal. Remember that one of the properties of a parallelogram says that the two diagonals cut each other in half. So QS has bisected PR, even though it doesn't quite look like it in my diagram. But if TR is 30, then PT must also be 30. Okay, so I'll stop there and we will pick up with another video in just a minute.